can you tell me if 7,58,799 is divisible by 11 in just 2 seconds without actually dividing it? Sounds like a trick, right? Hi, this is Harismita. Today, I'll be solving the divisibility rule must-do sums in must-do sums problems which are useful for your TANCET, MAT, placement, CAT, any examination that has aptitude. Okay, so hi, let's get started. How many numbers are divisible by 132? So these are the numbers. Let me check. If you're having 132, how can you write it in prime factors? So 132 can be written as 4 into 3 into 11. So these numbers, check if these numbers are divisible by 4, 3 and 11. Then those numbers are divisible by 132. So for checking if it is divisible by 3, go check the part 1 video of divisibility rules. I have given you easy trick to check it. Now let me check if it is divisible by 3. 2 plus 6 plus 4 is 8. 8 plus 4, which is 12. 12, so this is divisible by 3. Now 3 plus 9 plus 6 gives me 3 plus 9 plus 6 gives me 12 plus 6, which is 12 plus 6, 18. This is divisible by 3. Now let me check for 4 plus 6 plus 2, which is 12. This is also divisible by 3. Now let me check for 7 plus 9 plus 2, which is 18. This is also divisible by 3. Now let me check for 9 plus 6 plus 8. This is 15. 15 plus 8 is 23. So this is not divisible by 3. So we need not check for if it is divisible by 132. So we need not check the number at all for 4 and 11. Now let me check 2 plus 1 plus 7 plus 8, which is 18. This is also divisible. Now let me check for 5 plus 1 plus 8 plus 4, which is nothing but 6 plus 4, 18. So this is also divisible. This is also divisible. 6 plus 3, which is 9. 9 plus 3, which is 12. 12 plus, this is also divisible. Now again, let me check for 4 divisibilities. Okay. So let me check for 264. Last 2 digit is divisible by 4. So this is divisible by 4. Okay. Now next 96, right? 296, 396. 396 for checking if it is divisible by 4, you have to check for the last 4 digits. If you're having any doubts, check my divisibility rule part 1, part 2, part 3. I have given you all the theory parts which is used for solving these sums. Okay. Now 96, 4s are 1s are, 2s are 8. So this is also divisible. So this is also divisible. 62. Is 62 divisible by 4? So 62... No, it is not divisible by 4. So let's avoid this. 92. 92. I mean, next one you're having unit digit. Last 2 digits is 92. So when you check, you'll be having 2s are 8. So this is divisible. Okay. Now you have to check for last 2 digits of this. 78. 78 by 4. 1s are 4 balance 3, 38. So 38 is not divisible by 4. So this is also not there. And this number, it is remaining 84. Okay, 84, yes, it is divisible by 4. And 36, remaining is 36. Yes, it is divisible by 4. So what are the numbers? So the numbers that are divisible by 4 and 3 are 264 is divisible by 4 and 3. 396 is divisible by 4 and 3. Then 792 is divisible by 4 and 3. Then comes 5184 is divisible by 4 and 3. Then 6336 is divisible by 4 and 3. Okay. Now you have to check for your 11, right? So when I'm checking for 11, I have to add the odd digits and subtract with the even digits. So when I check for this will be 6 minus 6, which is 0. So this is divisible by 11. So same way when I check, this is 9 minus 9, 0. This is also divisible by 11. Again, I'm telling you, if you're having any doubts how I'm solving it, please go check divisibility rule 1, 2, and 3. Then when I solve it, again, this will be 9 minus 9. This is 0, so this is divisible. Now the odd digits are here. So which is 13 minus 5. 13 minus 5, so this is not divisible because 13 minus 5 it is coming. So it is not multiple of 11. Now 9 minus 9, which is 0. So there are 4 digits which are divisible by 4, 3 and 4 numbers that are divisible by 4, 3 and 11. So this is your right answer. 4 is your right answer. Now let me go to the next one. Next one, the largest 4-digit number that is exactly divisible by 88. Exactly divisible by 88. For it, you have to check whether it is divisible by 8 and it is divisible by 11 or not. Okay, let me check for 11 first. Alternative numbers, when I add, it is becoming 0. So this is divisible by 11. Alternative number, which is 15 minus 15, which is also 0. This is also 0 and this is also 0. So all these numbers are divisible by 11. Now let me check for the other things. Let me check for the 11 digits. Okay, 11 I have checked. Let me check for 8. So I have to check for last 3 digits. So 9, 4, 4, right? But it is divisible by 8 or not, let me check it. 4 ones are 8, so balance you'll be getting 6, 64. So it is divisible. Okay, so this is divisible. So we need not check other digits. Definitely it won't be divisible because it is an MCQ question. So this is a number that is divisible by 8 and 11. We don't have multiple options for it. So for your sake, let me check for other thing also. 9, 7, 6, 8. When I check it, it will become 2s are 16, 2s are, this is also divisible. So which is exactly divisible by 4-digit number. For this, you have to check the last, this I have checked the whole answer. But for this, you have to check the last 3 digits, but also it is also divisible. But in question, what did they ask? In question, they have asked you largest 4-digit number. So largest 4-digit number here is your A only. So your answer is A. Though all remaining things are divisible by other things, that is not an issue. You have to check for the largest 4-digit number that is divisible by 8. Even this is divisible by 88, but it is not the largest. Okay. So for checking for it, I just I didn't divide, instead of dividing by the whole thing, you can just divide by these things to get the answer. To know more about these questions, just comment yes for part 2, so that I'll be solving remaining questions, where an example of remaining question is this tricky one. So let me know if you're interested in solving these sums. If you want, I will do a part 2 video of divisibility problem part 2. Okay. So yes, thank you.